Hi guys, here are your notes on segment and angle relationships. So when we are doing proofs with geometric proofs, okay, you're going to get things like definitions, postulates, and theorems that are going to be your reasons to say each of your statements. So the first one you're going to get is called a segment addition postulate. So a postulate is just a statement that you're going to accept to be true, and you can use that to help you get through your proof when you get started with them. So the first one is saying if A and B are three collinear points and point B is between A and C, then AB plus BC must equal AC. Okay, so if you think of a little picture example, we have sort of been working with this before already. Basically, the two smaller parts will equal the entire segment. So we're going to use that in our first example here. So for this proof, we're just going to fill in the blanks. We've been told that segment JL is congruent to segment KM. So what I'm going to do is highlight them so you can see each segment easier. So I'm going to use pink for JL and blue for segment KM. Okay, and then you can see the purple part is where they overlap. Okay, so what we're trying to prove is that segment JK is congruent to LM. So we want to prove that the pink and the blue pieces are congruent to each other. So I'm starting with my given, okay? And then I went from saying that the two segments were congruent to saying that the distance between points J and L equals the distance between points K and M. So that's the difference between those two lines there, A and B. And my reason for that is going to be definition of congruent segments. Okay? Now, what I did in part C, I took JL and I rewrote it as JK plus KL. So if you look up here, those two together will give you JL. And then I did the same for KM. I rewrote it as KL plus LM. Okay, and that is an example addition postulate. Okay. After that, in the next line, if you look, I said JK plus KL equals KL plus LM. So all I did was take what I said in part B, and I replaced JL with the expressions I wrote in C for JL and KM. Okay, so D is just substitution. Okay, and then I subtracted KL from both sides using my subtraction property of equality, just like we had with the algebraic proofs, and saying that the distance between point J and K equals the distance between points L and M, and if the distance between those 2 points are equal, that means the two segments they create must be congruent, and that's definition of congruence, or you can say of congruent segments if you want to be more specific. Okay, so that's your first proof. We can write QED at the bottom there since we're done with that one. Okay, now the next three properties, you have seen symmetric property before. Okay, we use that in some of our algebraic proofs. So it also works for segments. So if you said segment AB was congruent to CD, you're allowed to switch it and say it the other way around. Reflexive property, we won't see much to start, but you will later. So saying AB is congruent to AB. And then transitive property, say I have three segments. One is AB, the other CD, and then we have a third EF. Say I knew already to start that AB and C were congruent, and then I also know that CD and EF are congruent. Okay, so then I'm allowed to say that AB and EF are also congruent. So they're linked through CD. Okay, and we'll work with that one more later. Okay, so if we look at our next example, it looks like we have a triangle. Okay, but what we're going to do is just work with the segments that make up the sides of that triangle. So my given is right here, and it's not labeled in the picture, so if they don't label your picture for you, always label it to give you a better idea of what they're asking in the proof. So we know that segment LK is congruent to NM, and that KJ is congruent to MJ. Okay, so that was given, and notice I marked these two with two congruence marks so we can separate them from MN and KL. Okay, and we want to prove that LJ is congruent to NJ. So I started with my given, okay, and then knowing that these segments are congruent, you can say that the distance between those points are equal. So what I'm doing is rewriting this out the segment bars and the congruent symbol, and that's definition of congruent segments. Okay, now this one is a little tricky and hard to see. Okay, you know LK and NM are congruent to each other, and okay, and then I'm adding KJ and MJ to both sides. Okay, and up here it said that these two were also equal, so I'm technically adding the same thing to both sides of the equation. So that's going to be just my addition. Okay, so even though I'm saying different letters, since they're the same length, you're adding the same length to both sides, so it still works for addition. You're still keeping your equation balanced. Okay? And then what I can say here, I can say that LK plus KJ equals LJ. And then I can say that NM plus MJ equals NJ. Okay, and then that's my segment addition postulate saying the two smaller segments add to the larger. Okay, and since I knew these pieces were equal to each other in C, I can replace those expressions, A and NJ, with substitution. And then now that I've shown the lengths or the distances between LJ and NJ are equal, that allows me to say that the segments formed between them are congruent segments. And that will be definition of congruence to finish the proof. Okay, so next in your packet are just some postulates and theorems about angles, okay, which you will use in your practice to do some angle proofs. So the first one is the angle addition postulate. So it's just like the segment addition postulate, except you're using angles. So if point D is inside angle ABC, then angle ABD plus angle DBC equals angle ABC. So the two smaller angles add up to give you the whole. Okay, next is your supplement theorem. So a theorem, and the abbreviation I use for that is just THM. A theorem is a statement that is true and it's been proven true somewhere. You don't have to worry about the proof, you just need to know it's true. Okay? So the supplement theorem, if two angles form a linear pair, so they form a line, then they are supplementary. And we did talk about this a little bit last week. So if angle 1 and 2 form a straight line, then we know that angle 1 plus angle 2 would add up to 180, since that's what supplementary means. Okay, and along with that, we have a complement theorem. If the non-common sides of two adjacent angles, so angles that are next to each other, form a right angle, then the angles are complementary. Okay, so if angle 1 and 2 form a right angle, then they are complementary, which means their measures have a sum of 90. All right, likewise with the reflexive, symmetric, and transitive properties you had for segments, they also work for angles. So reflexive, saying, for example, angle 1 is congruent. Symmetric, if you know angle 1 is congruent to angle 2, you're allowed to switch it and say angle 2 is congruent to angle 1. And then transitive property, if you have angle 1 and you know it's congruent to angle 2, okay, and you know that angle 2 is congruent to angle 3, then you know that 1 and 3 are congruent to each other also. Okay, congruent supplements theorem, okay? So if two angles are supplementary to the same angle, those two angles are congruent. So let's say if angle 1 and angle 2 are supplementary, so they add up to 180. And let's say that angle 2 and angle 3 are supplementary. Okay, so if you added angle 2 to both 1 and 3, you would get 180. So that means angle 1 must be congruent to angle 3. Okay, it works with complement also. If two angles are complementary to the same angle or to congruent angles, then those two angles are congruent. So we can say if angle 4 plus angle 5 had a sum of 90, and we'll say angle 6 plus angle 5 also had a sum of 90, then angle 4 and angle 6 are congruent angles. Okay, this next theorem on vertical angles, we learned what vertical angles were last week. Okay, vertical angles, no matter what, are always going to be congruent. So remember, vertical angles look like an hourglass. Okay, so you don't even need to know their measure to know, and then this pair would also be congruent. So they are always congruent no matter what. Just some theorems about right angles. Okay, so these are all proven true, and most of these might sound like common sense to you, but just remember, perpendicular lines form 4 right angles. Okay, so if these are perpendicular, all of these would be right angles. You'd have 4 of them. Okay, they all have a measure of exactly 90 degrees. And then perpendicular lines form 4 congruent adjacent angles. So all 4 of those angles are 90 degrees, so they're congruent, and they are all adjacent. Okay, and our last two, if two angles are congruent, they have to be a right angle. So say we knew angle 5 was congruent to angle 6, and we knew that angle 5 plus angle 6 had a sum of 180, then if they're both of them should have a measure of 90 degrees. Okay, and if you have two angles that are congruent and you know they form a linear pair, they are both right. Okay, so go through this packet. If you have any questions, look at the video again, try the practice on your own, check your answers with the key, and then try the homework, and we'll go over any questions you have tomorrow. Thanks, guys.